Hey everybody! The purpose of this little video is to walk you through some solutions to the Chapter 1 quiz. I called it a definitions quiz. Just the beginning of the book, kind of picking up some pieces for 243. The first is just 5 little one-point questions, basically definitions, making sure you know the difference between discrete and quantitative, and then quantitative discrete, quantitative continuous, or just qualitative. So let's go through them. Air temperature at Tumalo Falls. Well, that has to be continuous because you have to ask yourself, how do I get temperatures? Well, use the thermometer. And what is the thermometer doing? Well, it's measuring how hot or cold something is. And as soon as you realize, oh, it's a measurement, that makes it continuous. So temperature is going to be continuous. And if you remember in class, we talked about that. There's 4 continuous data types: temperature, time, weight, and length. So those are the 4 biggies. There are many others. For example, the amount of water falling over Tumalo Falls per day. Okay, it's a lot. I don't know what it is. Whatever it is, it's a lot. And whatever it is got to be continuous because I have to measure that. Very often the unit that is used is called CFS, or cubic feet per second. In this case, per day maybe. This is per day. But nonetheless, per day is a measurement. But more importantly, the amount of water falling over is also a measurement. Cubic feet. So feet is a measure of length, and cubic feet is a measure of volume. So therefore, it's got to be a continuous random variable. So that's that there. Number of people visiting Tumalo Falls on any given weekend. Now, very very often they'll measure they'll collect this kind of data. I guess you can call it measurement, although it's not technically measured. By a forest ranger, for example, sitting with a little clicker and keeping track of those walking up there. And think about how they click 1, click 2, click 3. That's counted. You count the number of people. You count a whole number of people. So that's going to be a discrete quantitative variable. Just like the number of trees in the area above Tumalo Falls is. That's also going to be a discrete. I wouldn't say you'd want to count that. It's kind of silly, especially when you talk about the area above Tumalo Falls, which is a measurement. But once you've defined that area, the number of trees in that area is most definitely discrete. And last but not least, the types of trees in the area above Tumalo Falls. Well, let's see. What do we have up there? We've got ponderosa pine. We probably have some larch, some western larch, maybe have a couple different kinds of firs, maybe a noble, maybe a white. Might be a juniper or two up there, although I think that's kind of a high elevation for juniper. But nonetheless, it doesn't matter because think about the data. I'm saying it's a ponderosa pine. It's a fir, grand fir. It's a larch. These things are types of trees. They're not numbers. You know, there's not a 1 type tree, a 2 type tree, a 3 type tree. And even if it was, that would just be a name. You couldn't actually do anything with those numbers besides just listing them out and maybe counting them. But nonetheless, the data itself is not numerical. The number of people, okay, is actually, 1 person, 2 people, 3 people, 4 people. The types of trees, fir, larch, pine, that's qualitative. Those are attributes of the trees. Those are attributes. Something gives them those attributes that then makes it be a ponderosa pine or a Douglas fir or something like that. So there's your first 5 points there. Down here, we go a little bit bottom. You get a little chart from the CDC's Tobacco Information and Prevention source page, and got a number of deaths per thousands, from a number of things. Smoking killed 418,000 over the course of this year. You might remember this statistic actually from Chris Jordan on the second day of class. We had a PowerPoint. Chris Jordan, the artist who had his that skull a cigarette image. It was made up of 200,000 packs of cigarettes that were, computer altered to be artistic. And if you remember, the reason the 200,000 was so special was because that's in 6 months how many people die from cigarette smoking every year. And this is the number he was pulling it from. This is roughly 400,000, so that's roughly double the 200,000. So there you go there. Kind of depressing, actually. And here are some other ones. AIDS, motor vehicle, alcohol, fires, homicide, illicit drugs, and suicide. Again, all causes of death. What does I say? Units on the vertical axis are thousands of Americans. Yep. Horizontal axis, these are all qualitative, killed by AIDS, killed by alcohol, killed by motor vehicle. The implication, hey, Sean, guess what? Smoking kills more Americans each year than anything else. And that's that claim, if that indeed is the claim that they're trying to get across, is definitely incorrect. So what I said, Google causes of death in Americans, and I'm going to go ahead and just copy that. We're going to open a Google window. Got a lot of them open already. And we're going to slap that in right here, causes of death in Americans. And here she goes. I'll take the quotes off. That's a little too specific. Okay, and I said look for a CDC page. So here's one here. Here's one here. This is not a CDC page. 15 most common. Let's look at a couple of these. Leading causes of death. And you might notice that heart disease is right there at the top, about 600,000 people. Now, if you remember back to our quiz, which is here, heart disease is not on here. Now, granted, heart disease could be included in smoking and alcohol, okay? It could be included in any of these things. I mean, somebody could have a heart attack from a fire, but I don't think they're not getting at heart attacks. Heart disease, smoking, maybe illicit drugs causing heart disease, who knows? Alcohol. So if you add the 418 and the 105, that still doesn't add to 600,000. So there's obviously some other stuff besides alcohol and smoking that are contributing to heart disease, like genetics and other things like that. But heart disease definitely kills more Americans than smoking alone, even though they might be interrelated. Let's get back in here again. Cancer. There's another one right there. Cancer. Let's see how cancer ties into this. Cancer and smoking? Very much. Lung cancer. Big one. That's probably one of the things that kills people from smoking. A large thing, I would imagine. That's a study in itself. Let's see. Cancer, alcohol, cirrhosis of the liver. I'm not sure if that's considered cancer. But nonetheless, there's another possible reason. What else we got? Chronic lower respiratory disease does not kill as much as smoking. So basically, it's these two right here. Let's back out of here. Deaths and mortality. What are we seeing here? Number of deaths. This is a repeat. So we're seeing repeated data here. Okay, this is interesting. Number of deaths for 2010, 2.4 million out of 311 million-ish in the population. So that's interesting. Life expectancy is 78.7 years. Pretty cool. What is USA top 15 causes? Although I would almost bet, this is by county. But look, red. Oh, wow. Here's Deschutes County. Let's look at Deschutes. Heart disease, low. Cancer. In Deschutes. This is very interesting. I've never seen this before. There's Deschutes. 162 per 100,000. That's considered, I'm assuming that's considered in the normal range. So heart disease, again, let's go back to heart. Deschutes County. Low. You have a low heart rate. Heart disease rate. 156 per 100,000. Huh. Well, that's very interesting. 0.15%. Let's look at accidents. Look at accidents. There's some red. Oh, but Deschutes is still in the middle as far as that goes. So what? Yeah, I'm sorry. I'm getting a little distracted here, friends. My ADD is kicking in. Yep, we're on the low end of that one. What do you think we'd be high in? Hypertension? I can't imagine us being high in that. Nope, we're actually low in that. Parkinson's? Homicide? Nah, I don't think so. Nope, low in that. Suicide? Well, look at that. 17 per 100,000. Okay, so I don't know if you've caught that, but 17 per 100,000 is considered quote-unquote high by the whatever data this is coming from. Let's check the source on this. Not source. CDC. It is. CDC through 2010. But 17 per 100,000 is considered high for suicides, where 156 per 100,000 is actually considered low for, what was it, heart disease or cancer or lung, stroke, whatever it was. Very interesting. And look at the suicide. I mean, I don't know how they're deciding the suicide rates being high. I mean, let's look at blue. What's blue? 7, 9, 7. Seems like anything double digit or higher, well, hopefully not higher, but double digit is considered high. Is that the way it is for every state? Let's grab one with some blue. Nebraska, 8. Yeah, it looks like they've defined, well, I'm guessing. Nobody kills themselves in Sioux, Nebraska. Interesting. Looks, oh, no. Double digit. Yeah, okay, so single digits appear to be how the CDC has defined low. Anything other than that is medium or high. Do you remember? Back to Oregon. 17 per 100,000. Oh, and look, 9 in Morrow, Oregon is considered middling. Yeah, so the rankings are a little bit of a mystery to me, but nonetheless, that was a fun little tangent we got off on there. The point of this was to see that smoking does not kill the most people overall in America. It looks like heart disease does. Smoking might be a cause of heart disease, but smoking itself does not kill the most people, depending on how you define a malady. So anyway, I hope this helped you understand the quiz a little better, and we'll catch you in class.